Hello everyone. Welcome to our presentation on analyzing theoretical CPT and SPT correlations of soils in Kelani Valley. I am Kaushalya and my colleague Engineer Hemakumara. We are going to present our research today. Co-authors are Engineer Senarathna, Engineer S.Widanapathirana and Engineer Pannala. Our affiliation is Climate Resilience Improvement Project, Sri Lanka. Geotechnical investigations are very important to investigate soil properties and geological conditions of subsoils. The standard penetration test SPT and the cone penetration test CPT are most common types of in situ tests used in Sri Lanka for geotechnical investigations. Several studies have been carried out in the past to establish theoretical relationships between these two tests. This research assesses the possible applicability of a theoretical relationship between raw SPT N value and cone penetration tip resistance QC for soils in the Kelani Valley. Let's discuss about the description of the study. The geotechnical investigations were carried out on both banks of Kelani River, starting from Hangmella to Kaduwela, covering 20 km distance approximately. Under the Climate Resilience Improvement Project, we have carried out these investigations to estimate ground parameters for detailed design of flood embankments. Accordingly, 30 numbers of SPT tests at 1 km intervals and 54 number of CPT tests at 500 meter intervals were carried out at the site. Among them, 5 tests were carried out approximately at the same location within 0.1 meter proximity. Figure 2 shows selected locations of these 5 boreholes. Borehole depths were varied up to 18 meters. We followed British standards for ground investigations as well as laboratory testings. BS 5930-2015 code we used for ground investigations as well as SPT testing. CPT testing conducted according to the BS-EN ISO 22476 standard. Let's discuss about the strengths and weaknesses of these two tests. There are few unique characteristics of both of these tests. If we take SPT, it is the most common type of geotechnical investigation testing used in Sri Lanka. Therefore, it is well familiar for most of the geologists and geotechnical staff working at the site. And also, SPT is comparatively cost-effective. Most important benefit of SPT is its ability of extracting both disturbed and undisturbed soil samples for laboratory testing. SPT has few weaknesses such as less reliability and repeatability. CPT is convenient, efficient, reliable, repeatable, and a simple test. And most importantly, we can obtain continuous record of soil profile using CPT. But in Sri Lanka, CPT is comparatively expensive and also expert knowledge is required to handle the CPT instrument as well as to interpret the CPT test results. Why a relationship between these two parameters is important? As we discussed, both of these tests has its own characteristics and different parameters can be obtained from both tests. Therefore, in absence of one test, this correlation can be effectively used for obtaining required geotechnical parameters for preliminary evaluations and design purposes. Let's discuss about the soil categories of Kelani Valley. Kelani Valley is composed of alluvial deposits made of silt, sand, clay, and gravel, underlain by lateral and residual soils. Among these, we have selected 5 soil categories for our study, namely silty sand, sandy silt, silty clay, clayly sand, and gravelly sand. Over to you, Engineer Sajjana, to continue. Thank you.
Thank you, Engineer Kaushalya. Talking about the methodology, we have identified 5 main soil types at selected 5 boreholes and then classified each soil category relevant to the depth of each strata and location of the borehole. The correlations for SPT and CPT were derived for the selected 5 main soil classes performing linear regression. With this, direct proportionate QC versus N relationship was adapted. And these developed relationships were compared with the past studies. In the analysis, 5 soil types were recognized depending on the accuracy and consistency of data. The relationships that we obtained for SPT and CPT are tabulated in the following table. And you can see we have obtained the correlation equation and correlation coefficient for each soil category. Thereafter, the relationship between QC versus N is illustrated in the graphs as shown below. On the figure in left, the correlation between QC versus N for silty sand is represented, whilst on the right, it is for sandy silt. The relationships for silty clay, clayey sand, and gravelly sand are represented by these 3 graphs. Then, QC over N ratio for obtained relationships were compared with the past studies with regard to the soil type. Overall, it can be observed that there's a good agreement for the relationships that we have already obtained in the study when we compared with the past literature. The numerical figures which are shown in blue color show very good match with the past studies. We have used 10 past studies for comparison. 7 out of them are in line with those researchers. Let's go to the discussion and conclusion of our study. There were limitations of the similar researchers in the same region. Therefore, the derived relationships were compared based only on the soil type. As it was shown from the previous tables, there were good agreement with respect to the past literature. Talking about the further investigation that can be done in this research, we have developed only linear relationship for tip resistance of CPT and number of blows of SPT. Further, the researchers can find possibilities of deriving multivariable linear regression models, power relationships, and the logarithmic relationships. And also, they can use various variables such as sleeve friction, friction ratio, and mean grain size. And also, they can increase the number of data sets for more accuracy of this research. Furthermore, the test can be carried out at various locations in Sri Lanka for array of soil categories to further assert the relationships between the variables. Thank you for listening.